चलिए दोस्तों शुरू करते हैं without wasting a time. As we saw in the previous video, how to implement segment routing traffic engineering with the BGP color extended community. So in this video, we are going to use the BGP segment routing T with the on-demand next hop. So this is the topology we have. The same topology which we used in the last lab, we are going to use the same topology. So I have already configured the IGP ISIS, and on this ISS I have already configured the segment routing configuration also. And we are using this global block SRGP 16,000 17,000, and this is our P1 router, this is P2, and these are the P1 and P2 core routers, and these are the customer networks. So behind the P1 we have this prefix which belong to VRF blue, and behind this P2 we have a two prefix belong to customer network VRF blue. So in the case of on-demand next hop, so there will be no explicit path or no segment is required. So when we use this on-demand next hop, our head-end router, so in our case P1 is the head-end router, this will automatically initiate the segment routing policy to a BGP next hop once this advertising router will advertise the route with the required colors. So once this router P1 will receive the route with the required colors, so policy will be automatically initiated. So let's jump to the configuration. We will see what are the configuration we need required to implement the BGP ODN. So we will complete this config in the two steps. In the first step, we will implement the segment routing traffic engineer related configuration on the head-end router, and after that, on the advertising router in the P2, which is on this prefix 222.222.222.222, we will assign the extended community color with the blue. Okay, let's jump to the config. Let's jump to the head-end router to implement the segment routing TE configuration. So here we are on the head-end router. This is the P1 router. Let me show you quickly what is the current configuration we have in this router. Show router ISIS. So ISS process core is running. Okay, and this is the command distributed link state level 2 is required to fetch the TE database from IGP database. And these are the two commands required for the TE. And this is here we are enabling the segment routing with the ISS process. And this is the we defining a node signal prefix-sid for this P1 node 16,033, as we are using the segment routing global block 16,000 to 17,000. And this is the point-to-point config required as SRTE support on the point-to-point links, not on the broadcast links. Let me show you the BGP config also as the P providerized devices. So between the PE1 and PE2, we are running a VPN v4 address family. So this is the IP address of PE2, and we have activated in the BGP VPN v4 address family. And we have configured the VRF value. In this VRF, we have created the loopback. So these are the loopback 100, which is belong to VRF value. So let's jump to the configuration now. So now if let me quickly check the before the routes, which are the routes we are getting in the blue VRF. So these are the two routes we are getting 200 and 222. These routes are coming from the provider 2 router. And if we check the route, there will be no community extended community attached on these prefixes. So let's quickly check for this. VPN v4 unicast RD we have configured 1.1. So there is only this RT community, only this extended community saving. We are not getting any extended community here. And similar way, we can check for the 222 other prefix also, which is receiving from the PE2 router. So this is also single community. We have an RT route target only, part of VRF blue, and that's it. Okay, and these are the metrics, and this is the receive level, the VPN level. Okay. So let's jump to the configuration section. Segment routing, traffic engineering, we have to go. And under that segment routing, traffic engineering, we will do the on demand. So on demand, after that, this is the ODN on demand color. So this is the color number we'll define the P2 after do the configuration. configuration. After that, we need to define a dynamic, and then with option we have to take dynamic. So this one specify the path computation from metric with take. Okay, dynamic metric. Then under that we have to select the type, and then so here we going to use the TE metric for the path computation. So that's it. This is the only config required in the case of segment routing on demand next stop. Segment routing on demand will mention, and this is the color combination we will attach while advancing the prefix on the PE2 towards the PE1. This is the one we have done. So let's jump to the PE2 to do the config regarding the color extended community while advising routes from PE2 to PE1. So here we are on the PE2 device. Let's quickly go through the current config. Router ISS. Again, same way as we have seen on the PE1. Router core process is configured, segment routing is enabled, T related config is there, and prefix is 16044, and interfaces are put in the point to point which is configured. Show ISS neighbor. This was also connected with the P2 and P1 on these interfaces. We have configured the point to point link which we are using. And let's check the BGP configuration also here. On the BGP again, this is the VPN v4 address family initiated. This is the P1 address. It's causing the address family VPN v4. This is the VRF value which configured, and in this VRF value we have configured to logical interfaces loopback 100 and loopback 200. These are part of VRF value. Okay, so here on this P we need to configure first thing is extended community set. Okay, then we can put a color, let's say blue, and then we need to give it to number and set. This is we have defined the extended community. Let's define the route policy. A route policy name will be also, let's say, blue if destination in. We are matching this prefix 222.222. We are advertising this prefix from this PE toward provider edge 1 PE1. Then set extended community color, and we have defined blue else pass pass and if and policy. So this will be our policy. So we are matching this our source prefix. We are attaching the policy, setting the color. Let's jump to the BGP configuration now. Router BGP AS is our 100. Let's go to the neighbor. In the neighbor context, this is the IP address of PE1. Let's go to the address family VPN v4 unicast under neighbor context. And here we have to advertise the route policy blue in the out direction as we are setting the community while advising routes from this PE to our PE. Let's quickly check show BGP VPN v4 unicast advertise. Once we see the advertised routes, we can see that for this prefix 222, now we are attaching this extended community color 100. And similar way, one more prefix we are advertising, but we have not attached this policy, only single extended. There is no color community we have attached this prefix. So let's jump back to the PE1, do the verification part. So here we are on the PE1 part. So earlier we have seen the routes. Right? So there was a route, there was no policy here. This was coming from the direct. We will check these things. Extended community was the only RT thing. Let's again check the routes. The 222 prefix. So here it is. So now we can see that we have on this color, we have a binding seed in place now, and the so here This is the binding state is showing 24003. SR policy is color 100 now it's showing. And if we show the normal where we does not apply any color community while utilizing routes from PE2 to PE1, so that will be the similar way like we seen before. It's same way, correct? Single community only extended. There is no color community. There is no binding state into the picture. If we see the segment routing, traffic engineering policy. So now we'll see we have this T is up in the 2-minute active, and this is the BGP ODN, BGP on demand, and preference is automatically taking the 200. We did not define any explicit path. This path is also dynamic. This is going via from the P2 to last node PE2. Finally, it is the dynamic, and if we see the forwarding policy, traffic engineering forwarding policy, so this will show this is the label stack is imposing, and there will be entry for the binding seat also in the forwarding plane label, and where the binding seat was the 2 4 in this here. So this is the binding seat we have 24003. This will see, right? So this is the binding seat, the outgoing pop, and this is the outgoing fallacious sign. If we do the trace out now, trace out VRF blue triple two dot triple two dot triple two dot triple two source triple one dot triple one dot triple one dot triple one. So it's taking the same path. The P2 then PE2. This is the way we have seen that how we can implement BGP on demand next stop in the segment routing. Thank you.